Have you ever had that gut-wrenching, heart-stopping moment where your computer just dies? Well, we're going to turn that panic into a solid plan. In this explainer, we'll get into both prevention, keeping your computer happy and healthy, and the cure, how to become a tech detective when things actually go wrong. Let's dive in.
Oh yeah, we've all been there. 1 minute you're working, the next, just silence. And that sudden quiet is deafening, isn't it? It's a moment of pure panic. But what if you had a game plan? What if you knew exactly what to do next, or even better, how you could have stopped it from happening in the first place?
So, here's our roadmap. We're going to start with prevention. First, we'll talk about keeping your machine cool, and then we'll cover how to feed it the right amount of power. After that, if disaster does strike, we'll switch into cure mode. You'll learn how to think like a true detective, follow the key rules of the investigation, and finally, how to fix the problem and make absolutely sure it stays fixed.
All right, first up in our prevention playbook is temperature. You've got to think of heat as the #1 enemy of your PC's components. It just slowly cooks them over time, which leads to crashes and, eventually, total failure. So what's the safe zone we're aiming for? This is it. 90 to 110 degrees Fahrenheit, which is about 32 to 43 Celsius. That is the absolute sweet spot for your CPU. A good cooler's job is to keep it right in that range. And why does this matter so much? Because a cooler processor is a faster, more stable processor and one that's going to last a whole lot longer. It really is that simple. So how do we stay in that cool zone? Well, we have a whole toolkit at our disposal. You've got your basic CPU and case fans to get the air moving. Heat sinks are like little radiators that pull heat directly off the processor. Then there's thermal compound. That's the critical gooey stuff that makes sure heat transfers from the CPU to the heatsink. And for those of you really pushing your systems, well, there are even more advanced options. And this is a perfect example of one of those heavy hitters. Liquid cooling systems are basically a supercharged radiator for your PC. They pump fluid right over the hottest parts, soaking up all that heat, and then cycle it away to be cooled by fans. It is an incredibly efficient way to tame the heat from today's high-performance gear.
Okay, let's move on to the second pillar of prevention, and believe me, this is just as critical as cooling: power. Because all the cooling in the world won't do you any good if your system isn't getting the right amount of clean, stable juice. This quote on the slide says it all. Your power supply unit, the PSU, it really is the heart of your PC. If that heart is too weak, you're going to get random crashes, weird instability, or maybe it won't even turn on at all. This is the one component you never, ever want to cheap out on.
So how do you pick the right one? Easy. You just follow the 30% rule. First, you're going to add up the power requirements for every single thing in your case. And always remember, your video card is almost always the thirstiest component of all. Then, whatever that total is, just add a 30% buffer on top. That gives you a nice safety margin and room to grow. And finding that magic number couldn't be easier. Every single power supply has its maximum wattage rating printed right there on the label, just like you see here. That's the first thing you should always look for when you're buying a PSU. All right, time for a quick knowledge check. Let's put that 30% rule to the test. Imagine a system with a DVD drive, 3 hard drives, and a pretty beefy video card. What's a safe wattage for that power supply? Is it A, 250 watts, B, 1000 watts, C, 700 watts, or D, 150 watts? Take a second, what do you think?
If you said C, 700 watts, you are absolutely correct. Let's do the math real quick. All those parts add up to about 470 watts. Then we add our 30% safety margin, and that pushes our minimum need to just over 600 watts. So a 700-watt supply gives us a comfortable buffer for right now and for any upgrades we might want to do tomorrow.
Okay, so you did everything right, but something still went wrong. Your computer is on the fritz. Now what? Well, now we stop being a caretaker and we start being a detective. Because troubleshooting isn't about wild guessing. It's about a systematic, step-by-step investigation. Every detective needs a map, and this flowchart right here is yours. This is the universal strategy for solving pretty much any problem. You start by identifying the issue, you come up with a theory about the cause, you test that theory, and once you know what's wrong, you plan your fix. If you stick to the map, you won't get lost in the woods. So let's apply that map to a classic case file, the PC that just won't boot. This flowchart is your specific guide for that investigation. Notice how it works. It just asks a series of simple yes or no questions. Is there power? Is the monitor on? Do you hear any beeps? Every answer you give takes you down a different path, narrowing down the suspects until you find the culprit.
Now, every good detective has a code, right? A set of rules they live by. For computer troubleshooting, we've got 13 golden rules. We're not going to go through every single one, but we are going to highlight 4 of the most important ones, the ones that really form the core of any good investigation.
Rule number 1 is the bedrock for everything else. Approach the problem systematically. Don't just start randomly clicking things or swapping parts. Follow your map. Be methodical. Panicked, random actions almost never solve the problem, and honestly, they can often make things worse.
Rule number 6. This might be my favorite. Try the simple things first. I am telling you, you would be amazed at how many dead computers are really just suffering from a power cable that's a little loose or a monitor that isn't turned on. Always check the obvious stuff before you assume your brand new graphics card is toast. It will save you so much time and heartache.
Rule number 8 is a classic tactic: divide and conquer. If you think a piece of hardware is the problem, start taking out the non-essential parts one by one. If the computer suddenly starts working fine after you remove one of the memory sticks, well, I think you've just found your culprit. It's all about isolating the problem.
And Rule 12 is another one that will save you a ton of headaches. Use the least invasive solution first. Before you break out the screwdrivers and start taking things apart, see if a simple software update or reinstalling a driver or even just a good old-fashioned reboot can fix the issue. Start simple and only escalate if you have to.
So, you've followed the clues, you've identified your suspect, and you've figured out the solution. It's time to close the case. But wait, you're not quite done just yet.
Here's how you wrap up the case like a pro. Step 1, obviously, apply the fix. Step 2, reboot the system. Step 3 is so important. Verify. Don't just check if the original problem is gone. Check everything. Your internet, your printer, your favorite games. Make sure your solution didn't create a new problem somewhere else. And finally, the most important step of all, ask yourself, how could I have prevented this? That's how you learn. That's how you get better.
And really, that's the big takeaway here. There's no magic trick to taking care of a computer. The secret is just having a method. Whether you're trying to prevent disaster or you're deep in detective mode trying to cure one, having a systematic approach is, without a doubt, your most powerful tool.
So the next time your computer starts acting up, don't panic. Put on that detective hat. What's the very first clue you're going to look for? Is it a weird noise, an error message on the screen, or maybe just a cable that isn't plugged in all the way? You've got the tools now. Go solve the mystery. Thanks for watching.